Thank you very much. When last we left off, we had, I want to go to 7 because we are block 7, 1.6. B, there we are. Multiplying by 1. Now, if you wish to express the number 4.6 in scientific notation, you still need times 10 to the something. Okay? So in this case, you just want 4.6, so it needs to be 4.6 times 1, right? Because that's going to be 4.6. So what power can we make our 10 so that the power of 10 equals 1? That has to be a 0. So if you want to write 4.6 in scientific notation, it is going to be 4.6 times 10 to the 0. How many places did we move the decimal? 0. Right? So that should make sense. We moved it no places, so it is, in fact, 0. Sometimes people get messed up by this one also, and I'm not quite sure why, but I'm going to go over it just in case. We have 83.4. So if we move our decimal place by 1 position to get our single number in front of the digit, that gives us 8.34. And then that would be times 10. How many places did we move our decimal? We moved it 1 place, so you have to include that 1 there. You cannot just leave it as 10 with no exponent. You have to have the exponent. Otherwise, it is not in scientific notation. So up till now, we have looked at big numbers. And just as a quick reminder, with a big number, what do I mean by big? Big means bigger than 1, okay? With a big number, we move our decimal. Let's say this is on page 109. We move it 3, 6, 9 places. So that is going to be 9.3 times 10 to the 9. And because it is a big number, that's going to be a positive exponent. And you do have to keep the number of significant figures consistent when you're changing into scientific notation. So this number here has 2 sig figs, and this number here has 2 sig figs. What if I stuck an over bar here? What would that change it to? Yeah, and then I would have 4 sig figs, and then I would have to say 9.300 times 10 to the 9. Would I put an overbar over this 0 here? No, because the decimal means that we already know that it is significant. Okay. Okay, so those were our big numbers. Working with small numbers, so this means something less than 1, we do exactly the same thing. We move our decimal place. In this case, 1, 2, 3, 4 positions. That gives us a single non-zero digit in front of the decimal, so something between 1 and 9. So this is 7.6 times 10 to the, and we've moved it 1, 2, 3, 4 places. So it's going to be to the power of 4, but because this is a small number, small numbers less than 1, they need what kind of exponent? Negative exponent. So that would be times 10 to the negative 4. Okay. Here we only need to move it 1, 2 places. 1, 2. So that's going to be 10 to the negative 2. Okay. I got really excited here. I don't know. I was like, okay, so it's negative 10 to the negative 2. And if you really want to think about it, 10 to the negative 2 is the same as 1 over 10 to the 2, which is the same as, so we have 4.9 times 1 over 10 to the 2, which is the same as 4.9 over 10 times 10, which is the same as 4.9 divided by 100. And you can see that that gets us back to our original number. So if you needed proving, there it is. Okay. Again, you can count by threes. That just makes your life faster. 3, 6. So that would be 10 to the negative 6. Example 12, 3, 6, 7, 8, 9, 10. I don't know why I did that one. Anyway, that's 10. So that would be 8.35 times 10 to the negative 10. What if I put a 0 here? What would I have to do if I added that 0? I would have to add a 0 here as well. Yes? Okay. Going backwards. Scientific notation to standard notation. If you have a positive exponent, which we do, that means, is your number going to be big or is it going to be small? A positive exponent means the number must be big. So you need to move the direction that makes that number larger. Okay, so we're going to look at this and we're going to say, if I want to make 3.56 larger, do I move my decimal place to the right? Or do I move my decimal place to the left? Which one will make it larger? Moving it to the right. So it's positive 3. So we're going to move it how many places? 3 decimal places. So we go 1, 2, and then I've got nothing there. Okay, so I would need to add a 0 in here. So that's going to be 3, 5, 6, 0. Do I put a decimal at the end or not? How many sig figs in this number? 3 sig figs. So I need to have 3 sig figs here. If I put that decimal on the end, that gives us 4 sig figs. So no decimal. Okay? Just like that. Okay. 4.27 times 10 to the 5. 4.27. It's a positive number, therefore I need to make this bigger so the decimal moves to the right. 1, 2, and then 3, 4, 5. So I'm going to have a 0, 0, 0. We only have 3 sig figs, so we do not want to have a decimal there, so it will just be 427, 0, 0, 0. Okay. Keep the sig figs the same. Oh, here's where you might need to use the overbar. Take a look at this one. We have 3.960 times 10 to the 7. If we write that in standard notation, 3.960, we're going to move our decimal place 7 places. 1, 2, 3, 4, 5, 6, 7. That means we're going to have an extra 1, 2, 3, 4 digits on there. But now remember that we have 4 sig figs, and that 0 there is the uncertain digit. So how can I tell you that that digit is uncertain? Put an overbar. Put an overbar. That's the only way to do it. Okay? Yeah. I know. Don't worry. After this unit, you probably will never have to use the overbar ever again. Okay? Ever? Probably ever. Okay. Scientific notation to standard notation with negative exponents. So we now have a negative exponent. If the exponent is negative, the number must be small. So in other words, less than 1. So we need to take 3.7 and make it small. Which way will we be moving our decimal? Left. Okay, how many places? It's -3, so we move it 3 places. 1, 2, 3. So there's where our decimal ends up. And we put zeros in here. And so we would have 0.0037. Is good? Okay. I think you should always put a 0 in front of the decimal. Apparently, maybe physics teachers disagree. I just think it looks weird if you don't. Like, I've never seen it with no 0. Anyway. Okay, once again, negative exponent. Now, how many places do we need to move it? 5 places, so 4.16. I've given myself a bunch of room over here because I need to put my zeros, right? So I'm going to go 1, 2, 3, 4, 5. I'm going to plonk my decimal there and put in my zeros. And so that is 0.000416. And now you see why we've got scientific notation, because this gets awkward. Oh, did I do it? Hang on. 1. Oh, yeah. 4 zeros. So sorry. Thank you. Good on you for catching it. Okay. Same thing. Keep your sig figs. So if you have a 0 here, this is your uncertain digit. And so what we need to do is we need to say that that digit is still uncertain. So when we move our decimal place 1, 2, 3, we end up with 0.004. We need to keep that 0 as our uncertain digit. Right? We've got 2 sig figs here. And we have 2 sig figs here. Okay. So convert the following numbers into scientific notation, convert the following numbers into standard notation. There are a ton of them. How about you do the odd numbers? Yeah? Yeah, just do them right now, odd numbers. Just so I can come around and check and see if anyone's having any difficulty. Because I know some of you, this is old hat, you've done it lots before. Some of you, maybe this is brand new and you're like, what? What's happening? That's fine. Yes. Yeah, that works for you also. Okay, and I was going to come around and check and see how you guys are doing. This number here is a 1. Yeah, 10 to the 0 is 1. Anything to the 0 is 1. Yeah. Yeah, no worries. That's why we do these, just to make sure. Okay, so you remove it as a place of grams. Okay, and then you just move it grams. You have one. Yes. Actually, yeah, could you make sure that you do questions 7, 8, and 9? I know I said do the odd numbers, but 7, 8, and 9 are all the same number, but they're all different answers. Okay, so make sure you do number 7, 8, and 9. And I'll be back to answer your question in just a sec. Okay, there we go. So, 7, that's 2 sequence. Yes. 8, that's what numbers on the sequence. 6 on here.
So, 6.
Yeah, exactly. Yeah. So you just add extra zeros. Yes. Yes, decimal means how long it is. Fix the other thing. When we're doing something. But all the things happen here. Apple is much more easy. It's like, oh, there's a number of things. Yeah. Yeah. So. Yeah. Yeah. Oh, is there a perfect no because we're for this one just Pencil okay? Actually, I have a pen.
Oh, it's fine. It's not anything works.
Do you know what? I'll give you a pencil. This one's better. That one breaks a lot.
Thank you.
Yeah, that's good. Yeah.
No one would help me.
Okay, so what? Yeah. Okay. Okay, so when that tells you how to see it.
Yeah, I understand.
Yes, so your answer also. So you'll go root one, well, for now, and then we're gonna add some report rows. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And then times 10 to that. Questions? Good? Maybe? Are you sure? Okay, so. Yeah. Yeah. See, there is more. Well, these two have more things. Yes. How about you guys? Do you have any questions? No, you're okay? All right. The only thing here is what you're gonna do, if you're going to, instead of writing right line, right? Because right now you're raising everything to the power of 10 to the 5. You're gonna multiply by 10 to the 5 rather than raising it to the power of 10 to the 5. Does that make sense? Cool. Yes. Yeah. Times the negative. Let's see, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 34. Yeah. Yeah. Yes. Yeah. Yeah.
Oh, thank you.
Stop. Yeah, that's correct. Yeah, beautiful. All right. Are you? You have to have one digit. Yes. Yes. So for this time, yeah, yeah. So
Are you five? So like every time. 30.
two. Six, yes, there are six. So. This is Okay, lots of people are sort of finishing up, so I'm going to let you do some more of that for homework. Please drop by if you're having troubles, but I've got a question here before I keep going. Okay. Yeah. Number 5.
That's what I would be doing that. I'm working.
All right, we're going to just go and make sure that we have dealt with on page, come here. On page 114, we're going to deal with no notation. In other words, this is a no, don't do it. Okay, no notation. And you kind of already know it. Because you know that you're only supposed to have one digit in front of that decimal, and that digit cannot be a 0. So if you have 29.4 times 10 to the 1, and this is on page 114, page 114. If you have 29.4 times 10 to the 1, that is not scientific notation. What if I said, let's turn this into scientific notation? What would we have to do? We would have to move our decimal place one place to the left, which would give us 2.94. And this number got smaller. So the other half of the number needs to get bigger. Okay, and if that doesn't make sense to you, I'll explain that in a moment. So this got smaller by 10 to the 1. We moved our decimal place one place. This has to get bigger by 10 to the 1. So instead of having times 10 to the 1, we will now have times 10 to the 2. Okay? Now, if it's not making sense to you, like why, if it gets smaller and bigger and whatever, like let's say I had the number 1 times 6. That's equal to 6, yes? What if I made the 1 bigger? Say I made it a 2. What would have to happen to the other number in order for it to still equal 6? The 1 got bigger, the 6 has to get smaller, and it would become a 3. Okay, so if you make one of the numbers bigger, the other number has to become smaller. All right? So here's just an explanation of what we did. Key concept at the bottom of the page. Anytime you multiply two numbers, if you make one number smaller, the other must get bigger. So we have another example here, 3 becoming 2. 3 times 4 is 12. If the 3 becomes smaller, the 4 must get bigger. Let's try a couple more examples. Is this number in scientific notation? 0.4837 times 10 to the 2. No, you cannot just have a 0 in front of the decimal. So what do we need to do with our decimal? Move it one place to the right. So we now have 4.837. This number got bigger or smaller? Bigger. Bigger by 10 to the, whoops, by 10 to the 1. And so this number has to get smaller by 10 to the 1. So that's going to be times 10 to the 1 less than 10 to the 2 is 10 to the 1. Okay.
I thought one of the negative ones.
Why?
What?
So this number got bigger by 10 to the 1.
Yeah.
Yeah. This 10 to the 2 also has to get smaller
Yeah.
by 10 to the 1. So if we become 10 to the 2, 1 power of 10 smaller, that is 10 to the 1. Now let's prove that these are equal to each other, shall we?
Yeah.
Okay. Work with me here. Okay. Okay. Now, if are you good? Do you understand now?
I think I.
You think you do?
Yeah, this shouldn't be. Then this will become 48.37. This one, yeah.
Yeah. And guess what? This would also become 48 point,
Okay.
right? They're both equal to 48.37. Yeah?
Yeah.
Yeah. Okay. All right. How about this lovely one here? Example 3. Scientific notation or not scientific notation? That is not scientific notation because we've got 1, 2, 3 digits in front of the decimal. So we would need to move our decimal place 2 places to the left. So it becomes 3.48. This number got bigger or smaller? Smaller. By how much? By 10 to the 2 because we moved our decimal place 2 places. So now our power of 10 has to get bigger by 10 to the 2. Now, here's a question for you. Is that going to be 10 to the negative 3 or is that going to be 10 to the negative 7? Which one is bigger? 10 to the negative 3. Just remember when you've got negative exponents, the smaller the exponent, the bigger the actual number. Okay? Okay, example 4. Is this in scientific notation or is it in no-no notation? No. We need to move our decimal place 1, 2, 3 places to the right. So now we have 5.279 times 10 to the negative 3. No, not negative 3. Hold on. That number got bigger. By how much? 10 to the 1, 2, 3. So this has to get smaller by 10 to the 3. So is that going to be 10 to the 0 or is it going to be 10 to the negative 6? 10 to the negative 6. Okay? Yeah. So if you get kind of, oh, wow, is this number in scientific notation? No, we need to have an exponent. So I would like you to tell your partner what that exponent should be. Now I want you to think about this. 2.3 times 10 is equal to 23. So if we put 2.3 times 10 to the 0, that is 2.3 times 10 to the what? Times what? Times 1, which is 2.3. So do we want a 0 there? No, and I'll let you know on the quiz regarding scientific notation, everybody gets this question wrong. Because they want to put a 0 here, but it's not a 0, it is a 1. Okay, so if it just says times 10, that means times 10 to the 1.
The scientific is on Wednesday, right?
Scientific notation is not on Wednesday. On Wednesday, we are doing making measurements,
So
Yeah.
Like the pencil?
like the pencil. Okay. Is 4.6 in scientific notation?
Yes.
No, because we need to have times 10 to the something. So 4.6 times 10 to the what?
0.
In this case, it has to be 0. So you can do number 1. And we've got, what, 25 minutes left? So actually, how did you guys do with your making measurements on the weekend? Let's just take a quick look here. Okay, so right now we're looking at page 116, number 1. And we had previously done page 113 odd. And let's check in on this one. No. This one? Yes. No. What did I assign here? Did I assign 79 and 80? Yeah, I did already assign that. Let me look. I'm so sorry. Sorry for wasting your time like this. Chem 11. Homework. Do-do-do-do. Do-do-do-do. 79 to 83.
Oh.
How many people have finished 79 to 83? Yeah, it is. That's why you had all weekend to do it. Uh-huh. Oh, I'm sorry to hear that. That sucks. 79, 80, 81, 82, 83. Tomorrow we're going to actually learn to use a burette, so this will make more sense to you. I would actually like to go over page 83 right now because it's a little bit more complicated. Page 83. For this question, we're not going to worry about the substance we're measuring. If you want to, you can call it water or liquid, okay? This measuring device is called a burette. And tomorrow, we will use a burette so that you can get an idea of what it's like, get a little lab skill in there. All right, that is a burette. Page 83. Yes, yes. So this measuring device is not about containing liquid. You fill this thing up to the tippy top, all the way to the top, with whatever liquid it is. Here it happens to be P because it's yellow. Okay, no, it's not P. Okay, we would never do that. That is unhygienic. All right. But we would start at the top and we would let the liquid drip out so that eventually you have a smaller amount of liquid in the burette. Does that make sense? Okay. Now, up at the top, we have the number. You can get it when he's back. We have a 0 and we have a 50. So if we start at 2, let's just not worry about sig figs right this second, okay? So if we start at 2 milliliters and we finish at, let's just call this 8 milliliters, we'll do sig figs in a moment. How much liquid was dripped out? 6 milliliters, yes? That's how a burette is used. People always want to do weird things like they want to subtract the number from 50 or something because it reads upside down. It reads top to bottom. Okay, but you don't. You say up here I have my 2. Up here somewhere I would have my number 1. So if I am actually measuring this, I would say that my initial volume is either 2 point something or 1.99. Each of these little divisions, how much is that? This is a 2, this is 2.1, so this is 2.4, this is 2.5. All right, so that means that this one here would be 1.9. So if you wanted to measure your initial volume, what does the word initial mean? Starting. So if you want to measure your initial volume, which we can write as V with a little I down at the bottom, the initial volume is, you could say 1.99, because you're really close to the 2. Or you could say 2. If you wanted to call this 2, what would you have to say? Would it just be 2.0? It would be 2.00, because the smallest division is 0.1, and so you can go to the 0.01. Right? Whatever your smallest division is, you can go to one more place. I'll get to you in just one sec. We're just going to write this down. So we have 1.99 milliliters, or if you wanted to, you could say 2.00 milliliters. Both of these have 3 sig figs. And you had a question, yes?
Yes, my question was, when looking at control, when looking at the wires, the line, the curved line, it's so.
Yeah, that's a good question. So we have this curve in the line. Do you guys remember what that curve is called? The curve is called a meniscus. Do they teach you that in home ec anymore?
Yes.
Usually they do. Okay. Okay, so that is a meniscus. And you always read at the bottom of the meniscus. Okay? Always read at the bottom of the meniscus. Yeah.
Thank you.
So according to that, what would we measure our final volume here? It could be 7.9? Not 7.9, because 7.9 would be right here. 7.99? Or we could say 8.00.
It could be plus 8.00 plus minus.
8.00 plus or minus 0.01. Yeah. Question, how do you like my measurement? Have I recorded it properly?
No.
No. What have I forgotten?
First units.
I've forgotten my units, so I would need milliliters. I would need milliliters. What else have I forgotten? What am I measuring? What is this measurement called here? This is the
In the final volume.
final volume. So instead of writing final volume, I can simply write VF. F for final. Okay? Now, if you're going to calculate the volume delivered, that is the amount dripped out. So the volume delivered is going to be the final volume minus the initial volume. You have to write this. Do you remember how I said when I'm marking you, you're going to get like a mark for the volume, you're going to mark for having the correct number of sig figs, and for having the units. So that's a 4 mark thing, or maybe 2 if I make it a half mark each. Okay? Here, you get a mark for writing volume delivered equals VF minus VI. Then you can substitute in 8.00 milliliters minus 2.00 milliliters. You get a mark for putting in the number and the unit and the number and the unit. Now, if you choose, you could, if you want to save a little time, go 8.00 minus 2.00, all in brackets with the milliliter on the outside. That is also okay. And then your final answer would be 6.00 milliliters. So you would get 1 for this and 1 for the unit. Yes? Okay. So you always, once again, have to write the formula, plug in the values with the units, calculate the final answer with the units. That's how you do science, right? If you don't write out that stuff, then nobody knows what you're talking about. And if nobody knows what you're talking about, they cannot repeat your work. Okay? So actually, I think I might just get you to do... Ooh, here was a good one. Number 17 on page 86. Okay, so homework, page 116, number 1, 113 odd, page 86, number 17, and get caught up on anything you haven't done. Like if you did not do pages 80 through whatever, I'll figure out what it was in just a second. Catch up on 79 to 83 if you've not done them yet. If you want a little extra help before tomorrow's quiz, we've got a few minutes right now, not a lot of minutes, but a few minutes. We also have I'm here after school today, and I'm here at lunchtime tomorrow, okay? So let's start a new post here. If you want to take a picture of the homework, it's there. And that is Monday, February 3rd.
It's like that, but just not shit. Like, had to have like a whole they gave like special shit. It's like in the back you can slip. So then, like I had to have like grip. Yeah, bro, I'm okay as shit. I was so bro, I would always wear it. But fucking, you know, I'm mad at someone. I'll wear the hat. And then, bro, I have a cup where I had a cup.
Yes.
Bro, my man just done with that. Or didn't know. Oh my god. I'm not saying to you. Not like, I would hang out with them outside. Okay, there was one girl who worked there. It was like this. Yeah, she's trying. But like, fuck yeah. It was funny sometimes. Like, I'm maybe I'm like loving it. Well, like, bro, it would never be that deep. It's like, it's like, and then fucking, like, at the end of the day, me and her were like, we're friends, but like, really chill and like, even though.
This is okay.
Yeah, that's what I like when she was friends with college, she was friends with like a couple of people. So
Okay, there's zero. The definition is that incorporated. So.
the longest shit I've had.
Because
fucking, I had like, I wasn't supposed to.
Yeah. Yeah. Not just water. And then you can say, human rock equals. Yeah. Remember. Okay. No, that's okay.
Hi, sorry. This cord is in the way. Fix that.
Oh, so do you have a question?
Yes.
Yeah.
Should I read these 2 pages for tomorrow exam? Just
For
this-
Tuesday's quiz, yeah, those are good practice for it, okay?
Okay, and I have another question. Can I take another exam for precision accuracy? Another.
You can write it after school today. You can write it tomorrow during flex. You can do it tomorrow at lunch.
Should
tomorrow
I
after
read-
school?
Should I read again or no?
Oh, should you prepare for it again?
Yes.
Yes, you can. So if you want to prepare for it some more, have you done, we'll start with this. So have you done all of this?
Yes, I.
Yes, you've done all of that? Okay, perfect. Have you done all of this?
No.
Okay, you could try this one. Okay, so that's page 40.
Okay.
All right, that's the extra practice.
Yes.
Okay,
Should I just read that or?
you can, you know what I would do? These are exercises, so you would do the exercises and then you can check in the answer key. Yeah?
After that, I can come here to take the exam.
Yeah, and if you have questions from here, if you're not sure about something, you can ask me before you write the quiz.
Okay.
Okay?
Thank you.
Yeah. You're welcome. Oh, tired today.
Yeah.
It's Monday.
It's Monday, of course. I'm always tired by last block of the day. I'm ready to go to sleep.
Thanks, too.
Yeah,
Of course.
of course. You just can't stay away.
Yeah,
Just love it so much.
this class is so awesome. You have to come back tomorrow. Yeah.
Oh, it's your pen.
Thank you. What, for the next block?
It's fine. That was just.
Okay.
How are you?
Good. Tired, but I'm always tired by last block, so just gotta keep going. We can all do it. We can all do it. We can get through. Right, young look. We can get through, right? Yeah.
So